advanced diploma, Bachelor of Applied Engineering. So we're talking about the E104A DC theory, transportation, graph, and a numerical expression. So they are the formula sheet. Those formula sheets are talking about the DC theories are required formula sheet. So this is the resistor, capacitor, and magnetic circuit formula sheet. So this is for the transportation graph and expression. For example, when a voltage increase, current increase, the graph can be drawn like this. So this is for the graph and the numerical expression. So the objective is that we have to apply the rule of the transportation to simple mathematical equation, identify the common type of component graph, draw the graphs and expect from the information from the graph, convert the whole number to scientific engineering and standard notation, and state the metric system, multiple and sub-multiple, convert the numbers between the conventional numbering system. This is rule of transportation. That what do you do to one side of the equation, you must do also do to the other side. In this case, remove the square. To remove the square root, both sides you have to make the square. So therefore, the I square equal to B by R. I equal to square root of B by R. So both sides square. So this is I square equal to B by R. Z is the square root of R square plus A square. So in this case, both sides square. Z square equal to R square plus A square. Also, you have to remove the fraction. I square equal to B by R. In this case, the remote fraction is that the I is multiplied to this side. B equal to I square R. B equal to B square by R. So in this case, this one R to cross multiply to this side. So B square to B R. Remove the bracket. So W equal to E brackets are B plus 0. In this case, W equal to E B plus EC. A equal to H multiply bracket B1 plus B2. So in this case, when you open a bracket, A equal to HB1 plus HB2. Collect the like terms. In this case, RS equal to FS plus FR. In this case, F is a common. So in this case, the like term is a FR is a one side. So Fs go to other side. So Fs go to other side is RS minus Fs. FR equal to RS minus Fs. 5L equal to 9C plus 160. In this case, 9C equal to 5L minus 160. Fr equal to Rs minus Fs. In this case, you can make this a common factor. Fr equal to, so here S is a common factor, take out. So S equal to, in the bracket R minus F. A equal to AA square plus CA square. In this case, A square is you got the common factor. B equal to A square in the bracket A plus C. We have to divide both sides by the coefficient of the new subject. Fr equal to S into R minus F. In this case, S equal to Fr divided by R minus F. AW square equal to 100H. In this case, H equal to AW square divided by 100. B equal to KV square. In this case, B square equal to P by K. Take the root of the both sides. If you see the V square equal to P by R, V equal to square root of R by K. V square root MA by K. So in this case, V equal to square root of MA by K. So the step of the transportation, you have to remove the roots square root sign. You have to remove the fraction, remove the bracket. Collect the like terms, get the desired terms on the one side of the equation, remove the new subject as the common factor, divide the both sides by the coefficient of the new subject and take roots of the both sides. The next one is what is a graph? Graph is a pictorial representation of two or more latest set of the data. So this is the graph. This is voltage and the current graph diagram. And here is the graph is the voltage and current. Part of the graph is AC. Also the origin. Also this is the abscissa and independent variable. So this is the ordinate. The dependent value is a y is it, and independent value is a is it. The point on the given graph is given in the coordinate. So this is the h1 and y1. This is a coordinate. This coordinate is h3, h2, y2. And part of the graph is the x is the path. Independent variable x. So independent variable is here. Dependent variable y is here. So in this case, x equal to 10, y equal to 8. So h 10 here, y equal to 8. So this one you can allocate. H20, y 16. H 20, and Y6 in here. 830, Y22, 830 and a Y22. 840, Y28, 840 and Y28. 850, Y22, Y33. 860, Y37, 870, Y41. 880, Y44. 890, Y47. So this is for the, by linking the two point, you can draw the graph. So it's the y equal to 2x squared minus 4. We have to draw the graph. In this case, we have to put x graph. You put the minus 3, minus 2y, minus 2. Also the up to the 2y3 you can put. And y value is a dependent variable. You substitute equation and you can calculate. In this case, 2 into, if you put the x minus 3, so 2 into minus 3 squared minus 4 is 14. Similarly, these are 2y5, 2, 1y5, 1, 0.5. So then you put, then you can calculate the y value. Those y values are you can draw on the scale. So this is the y x value and y value you can put on the scale. Then you draw the graph. So you can connect. So you can draw the graph. So this is the y equal to 2x squared minus 4 graph. Multiple, sum multiple, and the side effects are notification. So time and symbol is a multiple. Unit can be the meter and kilo, millimeter, meter, mega. So this is what the relationship between the symbol and the multiple. Data is a number 12, giga, number 9, mega, number 6, kilos are number 3, milli is a divided by 1000, micro is divided by the 1 million, nano divided by 10 power 9, pico is divided by 10 power 12. So this is the way size-weight notation you can write. So this is the size-weight notation for the tera, giga, mega, kilo, unit, milli, micro, nano, pico. You can find the size-weight notation. So this for the, in this case, are up higher, this is the lower. So today's lessons are we talking about the multiple and the size-weight notification for the electrical trade. So we also taught that applies electricity. We're talking about the electrical circuit. So this is for the, we talk about the Greek dependent independent variable. We draw this graph for the dependent independent variable. So this is for the this graph dependent also that this is for the voltage and current relationship. This graph we can draw. Y equal to 2x squared minus 4. And electrical circuit include this is battery here, and this is for the resistor and this switch and the light. This is the electric circuit. Battery, resistor, and also the fluorescent light, control switch, and the light. So that in this case, at the end of this session, you can describe the electromotive force, describe the electrical current, describe the electrical resistance, draw the simple electrical circuit, define the starting electrical turns, measure the voltage current in the simple electrical circuit. Now we're talking about the concept and terminology of the electrical circuit. Electrical pressure. Electrical pressure is a electromotive force EMF or the potential difference PD. Electric current flow. This is for the current I. Opposition to current is resistance R. Each of the flow is a conductance. So this is for the electrical current flow. Low pressure, low flow. More pressure, more flow. So the flow is a directly proportional to the pressure. Because in this case, alpha is proportional to. Pressure is depending on the voltage, electrical pressure voltage. In this case, electrical pressure is electromotive force. We use a symbol letter as E, terminal voltage or the potential difference V. So the unit is a volt. Flow is a current. In this case, electrical current flow. In this case, current I, unit is a ampere A. Opposition to flow is a resistance. In this case, we want to use the resistance opposition to current flow. Last part have the less opposition to flow. Flow is a inversely proportional to the opposition. Flow is inversely proportional to opposition. Opposition is a resistance. In this case, opposition to current flow is resistance. Unit is R. Letter is R. Unit is O. Each of the current flow is conductor G. Unit is a Simon. Electrical current circuit. In this case, battery include. This is the electrical load, switch, and the resistance to our electrical circuit. We join the two things together, then we can form the electrical circuit. So this is the battery is an electromotive force. We can represent by this symbol. Electrical source also we can represent. This is for the electrical fuse. We can represent. This is light. Light is you can represent by this way. This also the resistor. This is switch. You can represent by open switch or the closed switch. So this is what a symbol, a component of the electrical circuit. All the battery, no battery represented by this way. We join together. Electrical light, we can represent by the resistor. This way. Switch, you can represent by the switch, and we join together. This is the way we can draw the electrical circuit. So we summarize. So the electrical pressure is electromotive force E and F. Potential difference is PD. Letters are the E and V. Unit is a volt. Electrical current flow is current. Letter is I. Unit is ampere. Opposition to current flow is resistance. Letter R and the unit is O. Each of the flow is conductor G. And unit is Simon. Then you have to use a meter. This is the voltmeter. We can measure the voltage. And we can indicate the voltage. In this case, this voltage is 2 volt, 5 volt, 6 volts are 7 volts are 4 volt. Also the 9.5 volt. So this is voltage. This is 0.5 volt, 2.6 volt, 4.2 volt, 5.4 volt, 6.6 volt, 7.4 volt, 9 volt, and 9.8 volt. This current 5 ampere, 1.25 ampere, 1.524 ampere, and 1.75 ampere. So this is the 0.7 ampere and 0.75 ampere, 10.5 ampere. This is the way you can indicate the current. So we also do this practical exercise. This is the connection of DC supply, and this is switch. This is voltmeter. So this is we join all the switch this way, and the voltmeter connected in parallel. So today's lesson we talking about the symbol notation and transportation, also the basic electrical circuit. Answer for the G063 page 31 to 64. So this is for the trade 2. So now we are talking about the applied electricity DC circuit. This is for the Bachelor Applied Engineering. We're talking about the lesson 3 and 4. Applied electricity DC circuit, we're talking about the electron theory. So in this case, our basic electrical circuit, this is open switch, closed switch, the battery, this is voltage source, this is lamp, this is the voltmeter connection, the ammeter connection, and this is fuse. So those are the diagram symbol of the open switch, closed switch, battery, voltage source, lamp, fuse, voltmeter and ammeter. So this is connection of the voltmeter, fuse, switch, ammeter, and leg. So this is measurement of voltage. This is a DC meter. This is reading 32 ampere. This is 11 volt. The DC meter 15 ampere. This is 17.5 volt. So at the end of this session, students should be able to list the three-stage method and the final associated term, draw the Bohr model of atom and the name, the path, define the calculate the electrical charge, and describe the electrical properties of material. Define the starting term associated with the electrical material. Describe the mechanism of electrical current flow in solid, liquid, and gas. So this is for the atom. So this is nuclear. Nuclear, this is electron moving around. This is the proton, and the neutrons are at the nucleus. Atoms are made of the three basic particles. Proton carry the basic positive charge. Neutron carry a low charge. The proton and neutron join together to form the nucleus, the central part of the atom. Electron carry the negative charge and the circle the nucleus. So in this case, the middle part is the nucleus. Nucleus includes the proton and the neutron and the electron moving around. So here is the orbit. This is a neutron, electron, those are the orbit. So this is the inside the atom. So in this case, the atom always has the electron, proton. Atoms are usually about as many neutrons as a proton. So this is hydrogen, is a 1 proton and 1 electron. There is a 0 neutron. Helium got the 2 proton, 2 electron, and the 2 neutron. Carbon, 6 proton and 6 electron, and a 6 neutron. As in the proton make the few kind of the atom. As in the neutron make the isotope of the dead atom and the heavier version of the dead atom. So this is the atom has as many electrons as a proton. Atom usually have about as many neutrons as a proton. Matter can be classified as a substance. There are hundreds of substances which are called the elements. So they are the kind of the this is the periodic table element. So this is the hydrogen. Hydrogen are mercury, Ag. This is boron. So this is the atomic weight. Substances are made of the 2 or more elements are called the compounds. Some of the compound, there will be a compound with the nitrogen and chlorine compound. This is nitrogen chloride. So this is nitrogen chloride diagram. Hydrogen and oxygen compound, we call it a water. So this is called a 2H2O. 2H2 plus O2, then there will be 2H2O. So 2H2 is a gas, O2 is a gas, but the H2 is a liquid become. Liquid has a very different properties than the gas. So there are the diagram: oxygen, hydrogen, carbon, nitrogen, chlorine, fluoride. So this is carbon dioxide. Then this is the ozone. This is H2O. This is nitrous oxide. This is CFO, carbon fluoride. CH4 is the methane. Those are combination of the carbon, hydrogen, oxygen, and then we can call the substance compound. Substance which do not have the combined chemically are called a mixture. Wine and water they not mix together. Iron filling the wine. So this is the isotope hydrogen. So the hydrogen 1, helium is a 4, lithium is 6, sodium is a 22. In this case, the number of the electron here is a red is a number of the proton, blue is a number of neutron. So isotope of hydrogen, helium, lithium, and sodium. Electron inside the outer orbits are called the free or the valence electron. Electron as the outer orbits they are running. So this is the outer. The electron is outer. This is electron is outer. This is the free electron. They can move from the one atom to another atom. Material that have the loss of the free electron, they are called the good conductor. There are many free electron. They are good conductor. Very few are free electron. This is a pure conductor. Steel, copper, aluminum, silver. They are the good conductor or poor insulator. They got the a lot of free electron at the outer orbit. They are metal, steel, copper, aluminum, silver, gold. They are the poor conductor or poor insulator. Few free electrons are the good insulator or poor conductor. For example, rubber, plastic, mica, wood. They are the non-metal. Non-metals are the good insulator of poor conductors. So this is the atom, the neutral atom. Neutral ion, they got a 4 proton and a 6 electron. There's no charge, but the positive ion, in this case, are 4 proton and a 3 electron. So that will be positive charge. Here is a 4 electron, 4 proton. Red are 4 are proton. The outer orbits are the 4 are electrons. So they are neutral. But here you see the 4 are red, 4 red color, but the 3 outer electron. Therefore, the 4 electron is positive, 3 electron is negative. But the positive are more. This is when this ion called the positively charged. Negative ion means that this is the number of the electron. This is you can see the 5 electron, but the only 4 proton. So that will be negative charge. Charge behave with each other. Unlike charge, they are attract. Like charge, they repel. So conduction in a gas by the movement of ion. So the ion coming from the positive of the DC. So the movement to the positive ions are moving through now, and also they go to here to the other opposite terminal. So here in a gas. So they are movement conduction gas movement by the movement of the ion. So the conduction in liquid is also the movement of the ion. So you see that this is the supply electrode connected, the current flow, the red color, current flow. This is began the anode, and this is the began the positive charge. Positive are passing through to cathode. So conduction is solved by the movement of electron. So this is the movement of electron. When the electrons are the moving around, so electron flow is this diagram. The electrons are flowing. Electron flowing like this. And this is conventional current flow is positive and negative. So we connect the DC power supply to the light. So this is switch. So we make the MBR. So in this way we join the circuit together. So this is all the lesson 1. Then we're talking about the lesson 3 and lesson 4.
Lại kìa.
Nói này lâu mà on lên
Nghe
này.
hả chú? Lại kìa phải chú?
Nói này
Lại kìa.
lâu nè.
Lại kìa.
Xếp bằng cái
Mai chào chào kìa con mày. Thầy yêu quý rồi đẹp bộ. Ồ, thì không phải. Mau chết đẹp bộ.
Okay, we're talking about this DC circuits own law. In this case, electronic theory. So this is connection of the switch circuit diagram. Also that the voltage, when the voltage increase, current will be increased. And this is the median of the ammeter, voltmeter. So at the end of this session, students should be able to state their own laws, use their own law to calculate the voltage, current, and resistance in simple resistive current circuit, define the starting time associated with the electrical circuit. So in this case, the own law state that provided the temperature of the given conductor remain unchanged, the ratio of the potential difference between its and the steady current is a constant quantity. So V by I ever constant. We got this constant. This is where resistance. Resistance is a measure of the conductor opposition to electric current. The formula transportation, this is RVI. Resistor, I equal to V by I. Voltage is I multiplied by R. Current equal to V by R. So this is for the 12 ampere. Sometimes we 12 ampere current resistance 10 ohms. So the current we 120 divided by 10. So we have 12 ampere. In this sometimes we 240 volt. Resistance 10 ampere. So this is the 24 ampere. The increase in applied voltage gives the proportional increase in current. The current is a direct proportional to applied voltage. I direct proportional to V, or the I equal to V by R. So in this case, this is the exercise for the increment. Increase in resistance gives the proportional decrease in current. Because the supply 120 volt, resistance 10 ohms, so current flow is 12 ampere. Supply 120 volt, resistance 20 ohm, current 6 ampere. This means that increase in resistance gives the proportional decrease in current. So the current inversely proportional to resistance. I equal to inversely proportional to resistor. Resistance is a conductance. The electrical conductance is a measurement of the conductor is capability to conduct the electric current G equal to 1 by R or the G equal to I by V. So this is the DC power supply, V connection, and this is a connection diagram. So the lesson 4 that on this session, students should be able to analog the digital meter to measure the resistance, use the analog voltage and current meter to determine the current resistance, describe the two methods of connection of voltage and current meters to determine the circuit resistance, compare these two methods of connection. So resistance measurement, so this is for the digital meter, this is analog meter. Isolation resistance measurement, we use the mega. Which normally is we utilize the measurement of resistance. When R1, R2, R3, R4, and VB and VD are equal, that will be 0 volt. And galvanometer G indicates the 0. So the galvanometer G, R2 by R1 equal to R4 by R3. If R2 is only unknown, then R2 equal to R1 multiplied R4 divided by R3. Shunt method is a shunt method. Also use R equal to V by I. This is long shunt method. And this is the short shunt method. So long shunt method and the short shunt method. Supply voltage 99 volt, current 500 millimeter, I equal to V by I to 99.5, you got the 198 volt. Long shunt method, voltage 100 volt, I is a 300 milliampere to the I equal to V by I to 100.3 to 333 ohm. So this is long shunt method and short shunt method diagram. Now we're talking about the lesson 5. So we're talking about the effect of electrical current. Revision, we revise the Ohm's law. So when the voltage increase, current increase, voltage increase, current increasement. So this is a connection of the electrical circuit diagram. The reading of the voltmeter and ammeter. And this is resistance measurement, reading of the meter. Okay, at the end of this session, students should be able to list the effect of electric current, describe the effect of electric current is some example of the practical application, connect the electrical circuit to demonstrate the effect of electric current. The effect of electric current means that as a current flows through the conductor, machine causes heat. The current flow through the conductor, it causes electron always to align and producing in the magnetic field. If the current flow in the electrolyte, it causes a chemical reaction. Also, it can happen as psychological impact. This is always present when the electrical current flow. Harmful effects, they can be the unwanted heat, damage to conductor, and cause of fire. Useful effects is that we use for the cooking range, heater, frying pan, and refrigerator. Also toaster, incandescent lamp. Magnetism, when the electrical current flow, it can create the magnetic field around it. So this is the current diagram, which the current coming, the electric magnetic field is around like this. So the magnetic field will be this direction. So this is the currents are this way. This is the flowing to what? This is flowing away. Flowing to what? This is a magnetic field direction. Flowing away, this magnetic field direction. The current opposite, that will be the magnetic field will operate. So that will be the flowing away. This diagram, the flowing through. You can see this way. So magnetism is present when the current flow. The harmful effects are the attracted matter, distortion of radio wave. Useful effects are electromagnets and the motor. We can also use the generator, relay, and conductor. Audio recording and microphone. Chemical effect. When the electrical current flow, this is a chemical, so this is the electrode. This is the electrolyte. So the current flow like this, they become the anode. The current, this is the positive proton, positive charges, they flow to the negative charges passing through electrolyte to the cathode. So chemical effect. Harmful effects are the corrosion, useful effects are corrosion, rust, useful effects are electroplating, electrolysis, battery charging. Psychological effect. Harmful effects are the muscle spasm, pain, burn, stop breathing, death. Useful effect is defibrillator, stun gun, electrocardio, and electrofans, cardiac production, press. So those are psychological effects. The body system operates in response to the electrical impulse from the brain. The two most important muscles for survival are the heart and the diaphragm, both located in the chest. The power of the electrical current through the body is important. How much current can the body handle? Current and effect. Up to 2 milliampere, barely noticeable. 2 to 8 milliampere, sensations are noticeable and more painful. 8 to 12 milliampere, muscle spasm and more pain. 12 to 20 milliampere begin to lose muscle control. 20 to 50 ampere could stop the breathing. 50 to 100 milliampere could stop the heart. 100 to 200 milliampere will stop the heart. About 200 milliampere all the above and the severe numbing. So what affects the amount of the current in body? So that I equal to V by R. The current part, the longer the part, the higher the resistance, the condition of the part. Where all the damaged skin has a lower resistance than the into the dry skin. Then we are talking about the electromotive for EMS so that. So that the objectives are these are three main methods of the converting energy to electrical energy. These are two examples of electromotive source for the e-conversion method. Describe the principle of operation of common energy converter. Describe the difference between the primary and secondary cell and draw the equivalent circuit of the EMS source. Mechanical energy conversion, then can convert with electrical energy. So this is the energy conversion, the friction between two bodies based on the static charge. Mechanically driving generator use magnetic properties to create the differential potential difference. So this is the kind of the piezoelectric crystal. Piezoelectric crystal, mechanical energy convert to electrical energy. Friction between two bodies based on the static charge. Mechanically driven generator use magnetic properties to create the potential difference, and this is the function of the piezoelectric conversion, energy conversion, mechanical energy to electrical energy. Now we're talking about the chemical energy conversion process. So here chemical energy conversion, electrical energy. We use the electrode in the electrolyte to produce the potential difference between the electrode that they can be used as the primary cell or secondary cell. And radiant energy. Never radiant energy. So this is the energies are conversion process. Now and the radiant energy. So this is energy converted by electrical energy. He can produce the potential difference between dissimilar methods. He can produce a potential difference between dissimilar methods. So they are thermocouple. And in this case, we use the photovoltaic cell. Photovoltaic cell convert the sun energy to electricity. So this is the thing. So now we're talking about the voltage equivalent source. Ideal voltage source and zero internal resistance diagram and internal resistance diagram is this one. So that we have to talk about the effect of the basic current. So this is for the applied electricity, bachelor applied engineering degree aspect. Now we are talking about the diploma. Diploma, we read about the E082's engineering physics. So we go to the source, and it's both sides. Okay, we're talking about the electrical diploma. So the website is www.iuicollege.com/electrical diploma 2022.htm. So this is the website www.iuicollege.com/electrical diploma 2022.htm. So go down here, we can see the video lesson. Go down to YouTube video lesson for electrical engineering lesson. You click this side, then you click the lesson. We have all these I ask you to read to review the effect of the electric current. Here is a reading on the meter and also EMF. So now we're talking about the electrical power. So at the end of this session, the student should be able to state the power relationship in a DC circuit, calculate the power distributed in DC circuit, draw a circuit connection for the 1 meter in DC circuit, select the appropriate resistor for DC circuit, use a volt ammeter method to determine the power consumption in DC circuit, and use a 1 meter method to determine the power consumption in DC circuit. So the power equation is a P equal to VI. Here is a voltage, I is a current. So this is a connection of the electric turbine 24 DC, the switch, and the 5 ohm resistor. So when you connect, current will going down like this. The current is we mentioned about the flow current is 4 ampere. Then we can calculate the power, but P equal to VI. In this case, voltage is 20 volt, current is 4 ampere. So 20 multiplied 4, you got 80 watt. So it's turbine voltage double, current also double. So in this case, the current turbine voltage double, the current double, so the turbine voltage is now 80 volt, current is 4 ampere, so that will be the 320 watt. So power increase by the 4. And when the voltage are triple, current also triple. So in this case, voltage current is voltage is 60 volt, current is triple, so 12 ampere. So the 60 watt multiplied 12, power becomes 720 watt. Therefore, the providing the resistance in the circuit remains constant. Power is proportional to the square of the voltage. So from the P equal to VI and the I equal to V by R, we can write down the P equal to V multiplied V by R. In this case, in the place of the I, you can put as V by R. So this V and V multiply, so P equal to V squared by R. And from the P equal to IR and the V equal to IR, you can see that the P equal to I multiply I make R because of the P equal to VI. So in this case, V is equal to IR. So IR multiply another I. So this is P equal to I square R. This is power equation. P equal to VI. When you transpose the equation, I equal to V by R. So equal to V into V by R. So the P equal to V square by R. Now the V equal to IR. P equal to I multiply R. So the P equal to I square R. So therefore, to calculate the power, you use an equation P equal to V square by R or P equal to I square R. So this is the connection. This is a connection diagram of the power meter. So here I give you the 1 meter MMP and so voltage. So when the current connection, the current will be flowing like this. Power is a voltage coil must be connected. So in this case, MA is a current coil. We want to do the voltage coil. So we have to connect like this. So we also have to do a practical exercise. Now we also mentioned about the watt, energy, and power. At the end of this session, students should be able to define the time associated with the watt, energy, power, state the unit of the time associated with the watt, energy, and power, calculate the value of factors associated with the watt, energy, and power, calculate the watt time in the electrical circuit, define the time, power in and power out, and losses for energy transfer system. You also have to measure. We know that calculate the efficiency of electrical appliance. Now, for is needed to read the 25 kilogram of ground, 2 meter in 5 seconds. And this is a 25 kilogram. You have to lift 2 meters. So F equal to MA. And mass A acceleration. So in this case, mass is a 25 kilogram. Why is acceleration A? A equal to EI gravity because of the you have to lift. So acceleration gravity 9 meter per second square. Therefore, the F equal to MA. So that in the place of the M, you substitute 25. A is a 9/8. So that 25 minus 9/8, you got a 245 newton. How much work is done? What is the time energy used to move the object some distance? So what is explained in joules? So work equal to energy. Energy is also equal to work. So the what work is done to lift the 25 kilogram block at 2 meters in 5 seconds. So how much energy is needed? In this case, 25 kilogram you have to lift is the work time finished. So that will be the 2 meter height. So F equal to W equal to F multiplied by S. What equal to force by distance. The force is a 245 newton. We already know. And distance is when you are lifting the 2 meters. So S is 2 meters. So W equal to 245 minus 2. You got there 490 joules. How much power is used? So power is the rate of the doing the work. We measure in the joule per second. The joule per second equal to watt. So that we have to lift this block. How much power is needed to lift the 25 kilogram block 2 meters in 5 seconds. So we live in the 25 kilogram by 2 meters. So in this case, power equal to W divided by T. So the W equal to 490 joule, we got T is at 5 seconds. So the power equal to 490 by 5, so joule per second or 98 watts. We got. So therefore, the W equal to P equal to VI, or the P equal to V square R, and W equal to V multiplied by I, or the W equal to V squared by R. So those are the equations to calculate the power. In this case, also that we also write down the power equation P equal to I square R, or P equal to W equal to I square R as well. So this is a nature average and nature test. Also, this is the reading. So when you read this bill, so you can also see the how much how much gas waves are utilized. So then you can read. So the chart is a per megajoule. They are paying for the energy. So in this case, this is for the sample of the energy bill. So maybe. So in this is kilowatt hour meter is the power multiplied time. So 1 kVA here 3/6 megajoule. So this is the energy in, energy out. So in this case, when your energy in, some sort of energy is used for the heat, overcome the pressure, overcome the windage, and the remaining will go to the output. Power is equal to VI, and losses are the copper loss and iron loss. So we calculate the copper loss I square R, iron loss is the V by T, and then output power is the P equal to V by T. So this is the way you got output power. Not all energy that is put into system use efficiently. So we have to know about the efficiency. Efficiency power output by power input. So the practical exercise 7 you have to do the feeding efficiency. So this is the number 6, and also we talk about the number 7. So we talking about the applied electricity. These are the resistance of material. We have to review the electrical power, what energy power, and you have to do the quiz. So resistance of material. At the end of this session, students should be able to state the physical factors that affect the system, describe how the physical factors affect the system, state the unit of resistivity, calculate the resistance of conductor given a physical factor, So resistance measurement of the material opposition to the flow of current. Copper is a good conductor and has a low resistance. Silicon is a CD conductor, high resistance. Rubber is good insulator and a high resistance. So this is the resistance of the material. One of these shares we have the higher resistance. This is a directly proportional to length. So in this case, because this one, the longer, the more resistant. So the I equal to directly proportional to L. I is a resistance, L is a length. So in this case, R1 and R2 equal to L1 by R2. We have the higher resistance. Then we use smaller cross in the area, we get the higher resistance. So resistance is directly proportional to the area. So when the area is higher, resistance will be lower. Area lower, resistance will be higher. So in this case, A equal to pi square by R square. I equal to D by 2, so that A equal to pi D square by 4. So I is a directly proportional to 1 by A or 1 by D square. R1 by A1 equal to R2 by A2. This is already given. So resistance depends on the type of the material. We can call it this property resistance I equal to directly proportional to rho. So here is a material copper, silver, aluminum, nickel. They are resistively. So therefore, when you compare the resistance, two resistance, we have to compare the spaces are resistant like this, resistivity. By comparing the resistivity, you can compare the resistance. So R1 and R2 is a rho 1 and rho 2. R1 and R2 is a A2 by A1. So this is for the R1 and R2 is D2 square by T1 square. So R equal to rho A by A. So don't need use substitute. The next one is the temperature, the coefficient of resistance. Like this session, students should be able to identify the low temperature characteristic for the specified component, describe the resistance affected by the temperature, calculate the resistance component for change in temperature, describe the basic operation of NDC and PDC thermistor. Identify the drawing standard symbol for the specific component. So here is temperature resistance. When the resistance is higher, temperature will also increase. Temperature increase, resistance will be higher. So that will be the higher temperature is higher, resistance will be higher this is a positive temperature coefficient PDC. Now when the temperature is increased, resistance decreases the negative impact. Negative temperature coefficient, so NDC. The temperature increase, the resistance remains generally constant, zero temperature coefficient. The temperature resistance of coefficient resistance. When the temperature is higher, resistance will be higher. So that one will be drawn. So that will be the temperature of copper. The copper wire is alpha equal to delta R by delta T. So that this is the R H minus RC minus divided by the TH minus TC. So that will be the resistance. R1 is RA is 1, RC is 0, and also the TA is 20, TC is minus 234. So by this way you can calculate 0.003937. So the copper resistivity is 0.004. So the temperature dependent on the resistor called the thermistor. So this is the PDC and NDC method of thermistor. Then we have to also follow the temperature coefficient. Exercise. Okay, sir. Lesson 8. DC theory. So we're talking about the applied electricity circuit, series circuit. So at the end of this session, students should be able to define a series circuit and draw the appropriate circuit diagram, state the basic laws of the series circuit, simplify the series circuit, calculate the voltage, current, resistance, and power of series circuits, describe the effects of open and short circuits in the series circuits. So this is the connection of series circuit R1, R2, R3 that are connected in series. These elements are series. When the electrical current flows, only one current path. So the current I1, I2, I3 are the same. The same current flow through each element to the current ID. ID equal to I1 equal to I2 equal to I3. So this is ID current flow rate. The absorbed charge of the body around the blue is equal to 0. This means that a body across the R1 is V1, body across the R2 is V2, body across the R3 is V3. So the V1 plus V2 plus V3 is equal to VD. So the absorbed sum of body around the loop is equal to 0. Because the V1 plus V2 plus V3 minus VD equal to 0. Kyaw body law. The applied body equal to the sum of the individual body. So the VD is the applied voltage, individual voltage are V1, V2, V3. So the addition of the all V1, V2, V3 is equal to supply voltage VD. VD equal to V1 plus V2 plus V3. So the VD equal to the V1 plus V2 plus V3. And the VD is a current is a 0.6 ampere flowing. So the resistance are the 5.6 ohm, 10 ohm, and 18 ohm. So the V1 is a 0.6 minus 5.6, 3.36 volt. V2 is a 0.6 minus 10 is a 6 volt. V2 is a 0.6 minus 18 is a 10.8 volt. So you add everything. V2 3.36 plus 6 plus 10.8, you got a 20.16 volt. So the VD is a 32, in this case are the 32 volt. So V1 16, V2s are 7 volt, V3 how much volt? So in this case you can see the VD equal to 32 equal to 16 plus 7 plus V3. Therefore the VD equal to 32 minus 16 plus 7, you got a 9 volt. So this is R1, R2, R3 are connected in series. So the B point and the C point are located. So from the A to B, voltage is a VAB. From the B to C, voltage is a VBC. Between C and D, voltage equal to VCD. And also the A to C, voltage equal to VAC. A to D, voltage equal to VAD. So this is how do we call it. So in this case, R total here, voltage total is given. So ID currents are flowing. So the voltage across R1 is V1, voltage across R2 is V2, and voltage across R3 is V3. So in this case, RD equal to VD by IT. So the RD equal to V1 plus V2 plus V3 divided by ID. So therefore, the RD equal to V1 by I1 ID plus a V2 by ID plus a V3 by ID. This equal to RD equal to R1 plus R2 plus R3. So this is for the how the Kyaw body law. So the RD equal to the R1 plus R2 plus R3. So RD in this case are the R1 5 ohm, R2 6, 4 ohm, R3 11 ohm. So the RD equal to 5 plus 4 plus 11. So you got there 20 ohm. So RD equal to this R1 plus R2 plus R3. R1 is at 35 ohm. R3 is at 22 ohm. R3 is 75. So we have to find out the R2. So 75 equal to 35 plus R2 plus 22. Therefore the R2 is equal to 75 minus 35 plus 22. So you got the 18 ohm. C circuit often called the voltage divider circuit. Supply voltage VCC are connection. So R1, R2, R3 are connected in series. So the voltage cross R3 is a VR3. VR3 is a voltage cross R3 and it's a portion of the VCC. So the current flow is a IT. I equal to VD by RT. So VD divided by R1 plus R2 plus R3 I total. VR3 is equal to the ID multiplies R3. Therefore, you got is a VD multiplied R3 divided by R1 plus R2 plus R3. So therefore, the total voltage is at 10 volt. And they are 1 kilo ohm and 3 kilo ohm resistors are connected. Series current total is ID. Method 1, ID here is divided. So in the total voltage 10 volt divided by the 1 plus 3 kilo is 4 kilo ohm. So the voltage 10 volt divided by 4 kilo ohm resistance, you got the 2 by 5 milliampere. So V2 is equal to 2.5 is the milliampere current and resistance 3 ohm, 3 kilo ohms. So you multiply, you got a 7.5 volt. Method 2 is we have to apply V2 equal to total voltage 10 volt multiply with the 3 kilo ohm divided by the 1 plus 3 kilo ohm. So you got the 7.5 volt. In this case, the total voltage VT, the total current ID, voltage cross resistor R1 is V1, resistor R2 V2, resistor R3 V3. So V total providing. So in this case, PT equal to VT multiplied ID. So then PT equal to V1 plus V2 plus V3 is a voltage addition multiplied by ID. Therefore, the PD equal to V1 I1 plus V2 I2 plus V3 I3. Therefore, the power total equal to the P1 plus P2 plus P3. Because of the P1 equal to V1 I1, P2 is a P2 I2, P3 is a P3 I3. Also, the P total is a I square RT1 plus I1 square R1 plus I2 square R2 plus I3 square R3. So the power total is V1 square by R1 plus V2 square by R2 plus V3 square by R3. By this way, you got the PD. C circuit, IT equal to I1 equal to I2 equal to I3, VD equal to V1 plus V2 plus V3, RT equal to the R1 plus R2 plus R3, VD equal to P1 plus P2 plus P3. So those are the series circuits situation. So the voltage VT, this is the R1 150 ohm and then this is R2 is 100 ohm. So the voltage across the R2 is 50 volts. So how you got is the ID equal to I2. So the I1 is equal to 50 by 100 is you got a half ampere. RD equal to R1 plus R2. So the RD equal to 150 plus 100, you got a 250 ohm. V1 equal to I1 R1. So the V1 you half multiplied by 150, you got a 75 ohm. VD equal to ID multiplied by RD. So the VD equal to half into 250, you got the 125 ohm. VD equal to V1 plus V2. So the VD equal to 75 plus 50, 125 ohm. P1 equal to V1 I1. So the 75 half, you got the 37.5 watt. P2 equal to V2 I2, 50 multiplied half is 25 watt. P equal to VT ID. So the 125 multiplied half, you got a 62.5 watt. What happens to the current if the circuit is developed and the open circuit? When the open circuit, ID equal to 0. What happens to the resistance of the circuit? In this case, RD equal to infinity ohm. Because the voltage called the V across the open circuit is a VCC. So this is what happened to the circuit if the circuit is short circuit. So in this case, the RD is short. So in this case, the ID will be higher, resistance will be lower. Voltage VA called the short circuit is, that will be 0. And then you have to do this practical exercise. This is for the DC0044 and also lesson 10, E104 lesson 10. We're talking about the applied electricity circuit, parallel circuit. So we have to represent the series circuit. Represent. Lesson 10 is a parallel circuit. At the end of the discussion, students should be able to identify the terms of parallel circuit and draw the appropriate circuit diagram. State the basic law of the parallel circuit. Simplify the parallel circuit. Calculate the voltage, current, resistance, and power of parallel circuit. Describe the effect of open and short circuit currents in the parallel circuit. So this is for the parallel circuit connection. Supply voltage VT, so R1, R2, R3 are connected in parallel. These elements are in the parallel circuit. So multiple current path. So in this case, you can see the current ID here. Path for the R1, R2, R3, multiple currents are flowing. Voltage called V1, voltage called V2, and the voltage called V3. The same voltage across each element. Therefore, that we can write down the equation. V equal to V1 equal to V2 equal to V3. So the current ID is flowing. So this is the idea is a less because of the current flow to I1, current flow to R2 is I2, current flow to R3 is I3. So that you add the all current plus ID minus I1 minus I2 minus I3 is equal to 0. The algebraic sum of the currents at the node is equal to 0. The total current ID here, I1, I2, I3 are flowing. We write down the Kirchhoff current law. The total current is equal to the sum of individual currents. This is Kirchhoff current law. ID equal to I1 plus I2 plus I3 equation. So this is a total current equation. And also the total current ID. The current I1 flow to R1, I2 flow to R2, I3 flow to R3. So R1 is 10 ohm, R2 20 ohm, and R3 25 ohm. Supply voltage 100 volt. So therefore the VD equal to V1 equal to V2 equal to V3. This is equal to 100 volt. So I1 equal to the 100 divided by the 10, you got the 10 ampere. I2 equal to 100 voltage divided by 20 ohm, 5 ampere. I3 equal to 100 volt divided by 25, 4 ampere. ID equal to I1 plus I2 plus I3, you got this 19 ampere. You got. R total is VD by ID. You can find out. Therefore, the R equal to VD by I1 plus I2 plus I3, you can get it. So this is R total calculation. GD equal to V1 by I1 by V1 plus I2 by V2, VD plus I3 by V3. Then they equal to the GD equal to G1 plus G2 plus G3, or the 1 by R equal to 1 by R2, 1 plus 1 by R2 plus 1 by R3. So the 1 by RT equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is a relationship. Therefore, we can find out the equations of 1 by RT, 1 by 120 plus 1 by 150 plus 1 by 100, 200. You got a 12 by 600. So this is 1 by 50. Therefore, the RT equal to 50 ohm. The circuit often are called a circuit current divider. IR3 is a current through the R3 is a portion of the I3. So therefore, the VD equal to ID multiplied by RT. IR3 is VD by R3. So IR3 equal to ID multiply RT by R3. You can get it. Similarly, to the powers of PT. So the current flow to the I1, current flow to R2 I2, and current flow to R3 I3. So the in this case, PD equal to VT multiply ID. So the PD equal to VT multiply I1 plus I2 plus I3. Therefore, the PD equal to V1 I1 plus V2 I2 plus V3 I3. You can get it. So therefore, the PD equal to V1 I1 plus V2 I2 plus V3 I3. PD equal to P1 plus P2 plus P3. PD equal to IT square I1 square by the R1 plus I2 square by R2 plus I3 square by R3. So PD equal to V1 square by R1 plus V2 square by R2 plus V3 square by R3. So 20 volt is the supply voltage. ID flowing and current flow to R1 is a I1, current flow to R2 is a I2. So I1 equal to 20 by 10 is a 2 ampere. I2 20 by 20, 1 ampere. ID equal to 2 plus 1 equal to 3 ampere. R equal to VD by I. So the 20 by 3 you got the 6.67 ohm. P equal to 20 multiplied by 2 is a 40 watt. You got P2 equal to 20 multiplied by 1 is 20 watt. P equal to 20 multiplied by 3 is 60 watt. PD equal to power total equal to 20 plus 40 is 60 watt. You can get it. C circuit condition. ID equal to I1 equal to I2 equal to I3. VD equal to V1 plus V2 plus V3. R equal to R1 plus R2 plus R3. PT is P1 plus P2 plus P3. When the circuit condition, I equal to I1 plus I2 plus I3. VT equal to the V1 equal to V2 equal to V3. GD equal to G1 plus G2 plus G3. And PD equal to P1 plus P2 plus P3. Those are the formula relation between the voltage current and the resistance of the series and the parallel circuits. For the series circuit, the current are the same. So the supply voltage, summation of all voltage. Supply resistance is the summation of all resistance. Supply power is summation of all power. This is a series circuit. Parallel circuit, supply current is equal to the branch addition of all branch current. Voltage are the same, and inverse of the resistance are total. Inverse of the total resistance is equal to inverse of the all the resistance. Power total is equal to the summation of all power. So this is for the series and parallel circuit equation. So in this case, you can see that what happened to the body is the body cause a component open circuit. So this is the resistance R2 is open. In this case, for VDA unchanged, but the ID will be increased. RD will be increased and the ID will be down. So in this case, when there's R2 is open, voltage total is unchanged, resistance will be higher and the current will be lower. What happened to voltage of the circuit is a short circuit. So that this IT is a short, it is VD equal to 0. The whole voltage will be 0. RD equal to 0, current will be increased. So there will be there's a short circuit. Then you do the practical exercise. And we see the lesson 11 of the DC circuit. So that in this case we are talking about the series and the parallel circuit. Series and parallel circuit. Series and parallel circuit. When to revelation the parallel circuit connection, lesson 7 is series parallel circuit. At the end of this session, students should be able to define the series parallel circuit and draw the appropriate circuit diagram. Take the basic law of the series parallel circuit, simplify the series parallel circuit, calculate the voltage, current, resistance, and power of the series parallel circuit, describe the effect of the open and short circuit in the series parallel circuit. Series circuit is all the ID where you can see the equation for the series and parallel circuit. Series circuit, current, voltage, resistance, parallel circuit, current, voltage, resistance. In this case, G equal to 1 by R or the R equal to 1 by G. So you can see the R parallel circuits on video. So they are the kind of the parallel circuit. Which R1, R2 is series circuit, R3, R4, R5 is a parallel circuit. R1, R2, R3, R6 is a series and also combination of the R3, R4 and R5. Here is a R1, R2 is parallel, R2, R4 is parallel. And this is a straight connection. This is a series connection straight, this is a parallel connection straight. So those are the series parallel. This is a parallel element are the multiple current path. So this is R2, R3, R4, R5 are the this is for the multiple current path. So this is for the parallel connection. So this R2, R3, R4, R3, R2, R4 is a parallel connection. So this is the parallel circuit here. The current will be flowing to this one, and also this way that we can combine by the RP. R3, R4, R5 by combination you can call it RP. So the multiple current part is R3, R4, R5 is this is for the parallel is equal to RB. Single current part is R1, R2, R3, and R1, R2, RB, and R6 combination equal to RB. And also this is for the equation is this connection here. So this connection given. So that in this case RA is equal to the R2 plus R3. You got the 100 plus 80, 200 volt, and RY. So this is firstly you have to add. R is 120 plus 80, you got the 200 ohm. RY is the RH and the R4 parallel. So the 200 and 200 parallel, you got 100 ohm. So this is what this one, you can got the 100 ohm. So this 100 ohm plus 50 ohm and 60 ohm, you got the 50 plus 100 plus 60, you got the 210 ohm. So this is for the connection diagram of this connection here. So this will be the RA equal to R1 plus R2. Firstly, the R1 plus R2 you add RA. So this will be the R1 plus R2. And RB equal to this 30 ohm and the 30 ohm parallel, you got a 15 ohm. And also this one, also the parallel, RC equal to R2 plus R5. So that will be the 20 ohm. So the RD equal to RC and the RC parallel, you got a 10 ohm. So that will be the, and the R total equal to this one and this one, plus this one, R7, R8. So you got 15 plus 10 plus R7 plus R8, you got this at 100 ohm. So this is the way we calculate the total current, total resistance. So this one you also have to make the connection. So the R2 and the R5 is a R2 and R4s are combination series, and R3, R5 are series. So the R3, R5 and the R2 plus R3 plus R5 and R2 plus R4, they are connected in parallel. So the RB equal to you can partially you can right R2 plus R4 is a 18 plus 10. So you got the and also R3 plus R5 56 by 27. So RB is this way the 28 and the 83s are parallel. So you got the 20 plus a 940. So this is what the 21 940 is this one. And R1 here, R2 here, R1 this one, R2 here. So the RB is at 20 by 94. So you got the condition. So the 33 plus 20 plus 94 plus 12, you got a 65 by 940. Then you have to calculate the I total current. So this is what the total voltage 20 volt and resistance at 35 by 94. So you 20 volt divided by the 65 by 94, you got a 303 milliampere. V35 is this voltage here. So that this 303 milliampere by 20 plus 9 volts, you got a 6 by 35 volt. So I24 you also have to calculate. So that will be the 6 by 35 volt divided by the 28. So you got the 22 to 6 by 60. 6 milliampere you got it. Therefore, then you also see that this connection R3 is a 60 ohm, R4 40 ohm, R1 R2 20 and a 16 ohm. So you add so the RB is a R3 plus R4. So that will be the 60 multiplied 60 per 40, you got the 24 ohm RB. So that this RB 24 ohm and so 16 ohm and 20 ohm you add, the total resistance will be the 60 ohm. And total current ID can be calculated. So that divided by the 60 ohm resistance, you got a half ampere. And voltage across V1 can also be calculated. Voltage across V1 is a current half and a resistance 20, you got a 10 volt. Voltage across V2 is a current half, resistance 16, you got a 8 volt. And voltage across VB is a current half and resistance 20 volt, you got a 12 volt. And for power total can also be calculated. In this case, the current is a half ampere and voltage is a so power to the voltage P1. So that will be the voltage is a 10 volt and the current half, you got a 5 watt. P2 is a current is a half and resistance is a 8, you got a 4 watt. P2 is a in this case you got the resistance square, voltage square divided by resistance. Voltage is 12 square by resistance, so there's a 2 by 4 watt. P4 is 12 square divided by 40, 3 by 6 watt. And also the total voltage power can be calculated. So that will the resistance voltage 12 volt and the current half you got the 6 watt you got. B total is a voltage square 30 square divided by the total resistance 60, you got the 15 watt you can get it. Therefore the PD equal to the 5 watt and 4 watt and 2 by 4 by 3 by 6, you got the 15 watt you can get it. Therefore, also the supply voltage 30 volt, resistance R2 16, R4 20, R3 is R5 20. So therefore, you can calculate is R4 and R5 parallel, you get this 20 and 20 parallel, you got 10 ohm, and R3, and so this 10 ohm multiplied R3, you got this 16 ohm. So this 16 ohm is a parallel with the another 16 ohm. So this one parallel, you got 8 ohm. Then this 8 total 8 ohm plus with a 2 ohm. So that we need total resistance is a 10 ohm you get. Therefore, the total current ID can be calculated. Supply voltage 30 volt. Total resistance is 10 ohm, you got a 3 ampere. And V1 can be calculated. V1 is a this is for the resistance is a 2 ohm, current 3 ampere, you got a 6 volt. And the V2 also we calculate. V2 equal to V5P equal to VT minus V1. So VT is a 30 volt minus V1 is 6 volt, you got a 24 volt you got. So this voltage is a 24. V3 equal to that you can also see there's a 1/2 ampere. So this current here 1/2 ampere because the current 1/2 volt flow. The 1/2 ampere by 6 volt, you got a 9 volt. So the V4 equal to V5 equal to VSP minus 5 V3 24 minus 9 you got is 15 volt you got. I4 equal to I5. This is the voltage is at 20 volt and the by resistance are 20 ohm, you got a 3 by 4 ampere. So this is the way that you can see the current and the voltage flow in this circuit. And power total can be calculated. The voltage is 6 volt and P1 voltage power can calculate the voltage 6 volt and current 3 ampere. So you got the 18 watt. P2 can also calculate that voltage 24 volt and current 1/2. So therefore you got this power 36 watt. P3 can also be calculated. In this case, our voltage equal to the 9 volt and current 1.5, you got the 13.2 watt. P5 also we need to be calculated. In this case, our voltage is a 15 volt and resistance is a current is a 3/4, you got the 11.25 watt. Then you can calculate the power total. So that will be that you have to add all the power across P1, P2, P3, P4, P5. Then you can get this 90 watt. You can get it. Okay, this is also that we also need to calculate the voltage P4. So in this case, the supplying voltage is 600, and also that you see that the voltage across this one is the resistance is 1000 multiplied, and then do the resistance combination addition, you got a 4 volt you got. And also the VB also calculated. The supply voltage is 6 volt divided by the 500 divided by 500 plus 1000, you got a 2 volt you got. And VAB also need to be calculated. Again, that will be the VA minus VB. So VA and minus VB you get. So the 4 minus 2 you got the 2 volt you got it. Then you have to do the practical exercise. So series per circuit. Regarding the advanced diploma, you have to set the site. Apply electricity DC circuit. So capacitor and capacitance. CDF per circuit you have to revise. Lesson 12 the capacitor and capacitor. At the end of this session, students should be able to state the basic function and draw the standard symbol for the capacitor. Describe the construction of the capacitor, list the component of capacitor and state their applications, say the relationship between capacitor and voltage and charge, define and determine the time constant of the RC circuit, calculate the instantaneous voltage and the current in the RC circuit, why the capacitor, electric component used to store the charge. So this is the positive charge on the positive plate. Here is a 2 plate. Within 2 plate, 2 metal plate, we put that insulation, separated by the insulation material. This is called a dielectric. Factor that affecting the capacitance. Dielectric strength, dielectric constant, Farad per meter. Capacitor type determined by a dielectric strength. Polyresistor is a general purpose capacitor. Paper capacitor is main voltage. And electrolyte is a polarized high capacitance for the small side. Titanium is a polarized high capacitance for very small size. And ceramic plastic, this is a kind of the capacitor. Air capacitor is low capacitance and variable. Dielectric, so dielectric is a constant Farad per meter. Crossing the area of the plate is a A. And also distance between the plate is a D meter. And C equal to EA by D. The unit of capacitance is a farad. 1 farad is a law of the capacitance. So we use a microfarad and a picofarad as well. Symbols are the fixed. This is the most common symbol. Polarized, variable, trimmer. Those are the kind of the capacitor symbol. So there will be the voltage and the charge characteristic. So when the voltage increase, the electric charge will increase. So this is the del Q by del V. This is the farad. This is the capacitance you can calculate by this way. So Q equal to C into V. Q equal to C into V. When the capacitor is at 47 microfarad, voltage 100 volt. Q equal to CV. So that you substitute C equal to QY, you got 47, you 10 more minus 100, you got a 0.47 microfarad. So supply voltage 25 volt, capacitor 100 microfarad. So Q equal to CV. So that means Q equal to 100 into 10 more minus into 25, you got a 2500 microcoulomb. We get it. VS is the supply voltage. So that will be the current we flowing. In this case, our positive terminal and a negative terminal body charge are happening. So sublime voltage Vs, when the current flowing, so this is electric current flowing capacitor, IT equal to the I maximum e power minus T by T. T equal to I into C. So this is a T, 2T, 3T, 4T, 5T. You can get it here. Then when the current time increase, the current will be going down. Corresponding with the this graph. So this graph you can also draw it. And also the charge circuit, V equal to Vs into 1 minus e power minus T by T. T equal to RC. When the time increase, voltage will increase. So voltage increasing, you can draw this graph like this. And discharge circuit is this is a capacitor. When the voltage charge already charged, and when the discharge, the current will be going down, going out, there will be the charge will be zero. So charge will be zero. So the ID equal to I maximum e power minus T by T. So T equal to RC, I maximum minus V by R. When there's a time increase, current will also be increased like this. This is a charge. In this discharge circuit, when the time going on, current will be going down like this. So this is discharge circuit. So this is a universal time constant graph, T equal to RC graph. You can also see like this. Current always start at the maximum. I equal to Vs by R. For the charge and discharge, current always fall. For the charge, voltage will be rising. So charge is this diagram. For the discharge, voltage will fall. The charge down is this diagram. So these are connection diagrams. The strict position A to B, 220 ohm and 100 microfarad capacitor are connected in series. Sublime voltage 32 volts. So that when you say it connected to the B, V is equal to 0, V equal to VA equal to 32 volts. So this is S equal to T equal to 0, straight from A to B. The current flow into here, I is equal to I, T equal to IR equal to 32 by 220, you got 145 milliampere. T equal to RC 220 multiplied by 100 microfarad, you got a 22 millisecond. After 110 millisecond, capacitor charge and the current stop. V equal to Vs equal to 32 volt and a VR equal to 0. And at the same time after, you can see a switch from the B to A. Then I equal to I equal to IR equal to 32 by 220, you got a 145 milliampere. And the T equal to RC, so 220 multiplied by 100 microfarad, you got a 22 millisecond. After 110 milliseconds, the capacitor discharge and the current stop. I equal to 0, Vc equal to 0, Vr equal to 0. Then you have to do the practical exercise. Then we are talking about another lesson. Lesson 13. Capacitor in series and parallel. Capacitor in series and parallel. At the end of this session, the student should be able to describe the reason for connecting the capacitor in series and parallel. Calculate and measure the equivalent capacitor in series and parallel circuits. Calculate the distribution of voltage and charge on capacitor in series and parallel. Measure the distribution of voltage on the capacitor in series and parallel. Determine the serviceability of capacitors in a state common. Capacitor connected in series has the same current. So here C1, C2, C3, the same current flow. Capacitor connected in series has the same charge. The total charge on the group of capacitor connected in series is the same as the individual charge. QT equal to Q1 equal to Q2 equal to Q3. QT equal to CT multiplied by VT. So that in this case, when capacitor is connected in series, the V total equal to V1 plus V2 plus V3. QT by CT equal to Q1 and C1 plus Q2 by C2 plus Q3 by C3. You can get the current. So 1 by CT equal to 1 by C1 plus 1 by C2 plus 1 by C3. So the 1 by, this is the equation for the capacitor connected in series. We can write down this equation. 10 microfarad, 15 microfarad, 25 microfarad, those are connected in series. So therefore the 1 by CT equal to 1 by 10 plus 1 by 15 plus 1 by 25. So CT equal to 4 by 84 microfarad. You got it. Then the QT equal to CT multiplied VT. 10, 15, and 25 microfarad connected in series, supply voltage 100 volt. QT equal to 4 by 84 multiplied 100. So you got that 484 microcoulomb. You got it. Then VT equal to V1 plus V2 plus V3. V equal to Q by C. So therefore, that we write down that V1 equal to Q1 by C2. So 484 by 10, 48 by 8 volt, 48 by 4 volt. V2 equal to Q2 by C2, 484 by 15. You got a 32 by 27. V3 equal to Q3 by C3, 484 by 25, 90 by 36. So then you add everything. 484 by 4 plus 32 by 2 plus 90 by 4, you got 100 volt. 1 by C3 equal to 1 by C1 plus 1 by C2 plus 1 by C3. 8, 12, and 24 microfarads are connected in series. 1 by 8 plus 1 by 12 plus 1 by 24. CD equal to, you can calculate a CD. Then the CD multiplied VT is a 4 multiplied 400. You got the 1600 microcoulomb. Q together 1600 microcoulomb. V equal to V1 plus V2 by V3. So in this case, we calculate V1 into Q1 by C1. 1600 by 8, you got a 200 volt. You substitute. V2 equal to Q2 by C3. 1600 by 12, you got a 133 by 3 volt. V3 equal to Q3 by C3. 1600 by 24, you got a 67 by 7 volt. So you add everything, you got a voltage equal to 400 volt. Then capacitor connected in parallel. They draw a different current. So C1, C2, C3 are connected in parallel. The currents are I1, I2, I3. Also, there are different charges as well. So the C1 charge are Q1, C2 charge is Q3, C3 charge is Q3. The total charge on a group of capacitor connected in parallel is the sum of the individual charges. Q2 equal to Q1 plus Q2 plus Q3. So therefore, you got Q2 equal to CD multiplied VT. Q2 equal to Q1 plus Q2 plus Q3. Then CD VT plus equal to C1 V1 plus C2 V2 plus C3 V3. So CD equal to C1 plus C2 plus C3. Just like making the plate larger, make the equivalent capacitance larger. So the Q1, C1, C2, C3 are 10, 5, and 15. You add everything. CD equal to 5 plus 10 plus 15. You got the 30 microfarad. QT equal to Q1 plus Q2 plus Q3. CD equal to 30 microfarad. The current flow to the capacitor C1, I1, capacitor C2, I2, capacitor C3 is I3. Then QT equal to Q1 plus Q2 plus Q3. Q1 equal to C1 V1 50 multiplied 5, 250 microcoulomb. Q2 equal to C2 V2 50 multiplied 10, 500 microcoulomb. Q3 equal to C3 V3 50 multiplied 15, 750 microcoulomb. So you add everything. Q equal to 250 plus 500 plus 750, you got that 1500 microcoulomb, you got it. Therefore, Q equal to 1500 microcoulomb. Then also that here capacitor 25, 50, 75 connected in parallel. C equal to C1 plus C2 plus C3. So you substitute the value of C1, C2, C3. So 25 plus 50 plus 75, you got that 150 microfarad. Qt equal to Q1 plus Q2 plus Q3. Qt equal to Q1 plus Q2 plus Q3, you got it. Therefore, here you see the thing is a 25, 50, and 75 you add. So the Q1, Q2, Q3 is you add everything. So the Q1 is the C1, V1, 85 minus 25, 2125. Q2 equal to C2, V2, 85 minus 50, 4250. Q3 equal to C3, V3, 85 minus 75, 6375. You add all of it. 2125 plus 427 plus 6375, you got a 12750 microcoulomb, you got it. QT equal to CT, PT is a Q1 equal to 150 multiplied by 85, so 12750. Then you have to do the practical exercise. Then we are talking about this is for the electrical engineering. Firstly, I explain you about the trade 1 and trade 2, so that you read them, view my video, and then you also view another video. Another video is no audio. You have to read the notes on the page. Then you have to study. This video is a guide. Today's lesson, there are 2 videos. This video I explain about what to read and also what the lesson. Second video, without any audio. My intention is that you have to read the video and you have to read the pages on this video. So second video is the electrical trade 1 circuit diagram connection and the cable termination. Trade 2 is the circuit protection. Those things you have to view the video. So this is the adjacent side hyper venue, and this is opposite side. So that at the end of this lesson, students should be able to state and supply the sine, cosine, and tangent ratio of the right angle triangle. Use a calculator to find the sine, cosine, and tangent of any angle. Apply the Pythagoras theorem to right angle triangle. So this is the right angle triangle. This is ABC. Angle ABC. So angle A is angle CAB is a theta. Angle B is angle ABC 5. Angle C is angle BC is 90 degrees. So this is for the right angle triangle. Side BC is A, side CA B, and side AB is C. So this is the name on the side. So this is A, B, C. You can see the angle theta, angle phi. This one is a hypotenuse. This is opposite side. This is adjacent side. So this theta, hypotenuse, opposite side, adjacent side. So angles, all the any angles are up to 180 degrees. So this is phi, theta, and 90 degrees, 180 degrees. So the angle A plus angle B plus angle C, the combination is 180, and phi plus theta is 90 degrees. So by the way, theorem. So this is angle theta A, B, C here. So that the square of the hypotenuse is equal to the sum of the square on the other 2 sides. So C square equal to A square plus B square. So here hypotenuse is C, adjacent side is B, opposite side is A. This is the ratio of the side. Sin theta is the opposite side hypotenuse, so that this is A by C. Cos theta is the adjacent side of hypotenuse, so B by C. Tangent theta is opposite side by adjacent side, so A by C. So this is the ratio of the side. So that this is the ratio of the side. Sin theta, cos theta, tangent theta equation. So this is the formula. So AE is a workbooks are example. So this is hypotenuse, the theta is 5, this is 20 meter, 12 meter. So that in this case, theta is cos about 12 by 20, so 53 by 133. So this is 53 by 133 is theta is a sine about 12 by 60, so 36 by 87 degree. This is 36 by 8 minus 3. Theta 5 equal to 90 minus 53 by 3, so you got 36 by 87. BC is the square root of B 20 square minus 12 square, so you got a 16 millimeter. So that will be the answer here. Hypotenuse and 100 centimeter, 34 millimeter. Theta tangent about 120 by 70 by 34. You got the 75 by 69 degree. AB is square root of 120 70 square by 34 square, 173 by 37 millimeter. So this angle is this angle 200 millimeter, 160 angle 5. So AC will square root of 200 square minus 160 square, 120 millimeter. So sine B is opposite by hypotenuse, so you got the 120 by 200 y share. Cos beta is adjacent side by the hypotenuse, so there will be 160 by 200, you got y Then you be like opposite by adjacent side. So 120 by 160, you got a 0.75. So the size here opposite by hypotenuse, so there we 160 by 200, 0.8. Cos here adjacent by hypotenuse, so the 120 by 200, 0.6. Then just see is opposite by adjacent side 160 by 120, 1 by 3 degree. So that will be there's a 0, 90, 270, 180 degrees. So this 0 degree here. Then rotated, this is plus 30 degree. Sin 30.5, cos 30.86, tan 30.577. So this angle is at 150 degree. So that this is the 30. So sin 150.5, cos 150 is a minus 0.86, tan 150 minus 0.577. This angle is a 270 degree. So that will be the sin 150 minus, this is minus 150 is a minus 0.5, cos minus 150 is a minus 0.86, then minus 150 is a 0.577. The angle is a minus 30 degree. So sin minus 30 is a minus 0.5, cos minus 30 is a 0.86, then minus 30 minus 0.577. So this is the both things are relationship. You can see the sin 30, sin 50, 150, sin 220, sin 330, we can put on this diagram. This is all sine, tan, cos. Because all angles are positive, ER is sine are positive, others are negative. This quadrant, tangent is a positive, others are negative. This quadrant, cosine is positive, others are negative. So this is the angles are 10 degree, 20 degree, 70 degree, those angle theta. We can find the sine, cosine, tangent, and the tangent angle. So those are angle value, you can read the table. Then you can do the problem exercise. Then we also talk about the alternating currents are quantities, AC quantity. So the problem in low voltage AC circuit, alternating current quantity. At the end of this lesson, students should be able to define the terms of alternating current and disadvantages, identify the basic weight shape and the list used for each. Second, the simple side weight and show the P2P and the RMS value as well as the period of the weight, calculate the value associated with the AC waveform, and also to define the stress and the form factor for AC waveform. So this is the common waveform diagram. This is for the square wave. This is for the sawtooth wave. This is a triangular wave. This is a sinusoidal wave. So this is general operation is this is a north pole and south pole electromagnetic field are flowing and the conductor is moving. So A to B. When the conductor moving here, so vertically, that will be VAB, rotate AB. And when the rotor rotate this way, so in the magnetic field, the conductor is rotating like this way. And conductor rotate this way, the current flow here, waveform here. So now this diagram, waveform and the current flow. Then this diagram, waveform and the current flow. And then this one will be a complete one cycle. The alternating current is like this. This is output generator is alternating. The voltage will be 0 to minus 90 and plus 90 like this. Alternating current quantity. So the average value of AC quantity is 0. Amplitude between the P of the AC quantity known as the P to P value. So this P to this P, the P to P. The half of the P to P value is now the peak of the maximum value. So PP is a peak of maximum value. VP to P is 2 VP. And the root mean square value of the AC quantity, the equivalent value to DC value, that would do the same work. So VP is the square root of 2 are the RMS. The time taken to complete the one circle on 360 degree is a period T. So this is a period T. So this is a period T. This is a period T. The frequency half of the waveform is a number of cycles per second. So F equal to 1 by T. equal to 1 by f. Any sinusoidal waveform can be described mathematically by Vd equal to Vb sine 360 ft or Vb sine 360 t by t, where the Vd is the instantaneous value of the sine wave, t is the instantaneous time, Vb is the peak value of the wave, f is the frequency of the wave, f equal to 1 by t. 360 ft is the angle of the instantaneous time t. Average value of the mathematical AC quantity is 0. So there is every value of the rectified AC quantity is 2 by pi or 0.637. The forward AC waveform is the forward VRMS or V average, so the pi by 2 to 2, you got the 1 by 1 1. The crest without AC waveform, the crest without V maximum VRMS is root 2 or 1 by 414. And then you do a problem exercise. Those are the advanced associate degree. I only talking about the trade 1, trade 2, also the AC quantity, so G102. So this is Bachelor of Applied Engineering. Then you also have to do the advanced diploma electrical. So we go to the site. The Bachelor of Applied Engineering. So this is a sort of problem in low voltage AC circuit. We talking about the CRO, cathode oscilloscope. And all of this session, students should be able to already adjust the control of the basic CRO, check the calibration of basic CRO, measure DC and AC voltage on basic CRO, use the CRO to determine the phase difference between the two sideways. So this is the connection of the diagram of the cathode oscilloscope. So you see that this is the cathode oscilloscope. This is a switch die, and this is for the channel A, channel B, so channel A, channel B switch. And this is inside of this cathode oscilloscope. So this is cathode. This is the accelerating electrode and electron beam. The focus electrode is into a deflection coil. And this is a phosphorus skin. So this is where all the electrical voltage across this direction coil, deflection coil. It will adjust the electron beam, and the electron beam hit the phosphorus screen, and light will be coming out. So there is coming out from the phosphorus screen. So this is the inside connection. Cathode oscilloscope, switch generator control system. It provides a horizontal switch, time-based control, millisecond and duration. So this is the three guys connection. Here is a triggering circuit. Synchronizing not this is about the switch triggering circuit. So this is the switch generator control, vertical amplifier control. So vertical amplifier control is we can adjust the volt duration. Vertical displacement control. This is the connected to the external input. So this is the connected to ground connection. So this is the volt duration for the external control. Volt duration, and this is the AC ground DC. This is for the also we can connect it to the channel 1, channel 2 dual mode. So this is for the in this case vertical scale 10 volt duration, horizontally 2 millivolt duration, trace center at the 0 point object. So this is the connection like this. And secondary DC, change the vertical scale 24 watt duration and leave the time wave at 2 milliwatt second duration. So that will be the answer like it happen like this. And this is the vertical scale 1 watt duration, horizontal scale 0.1 millisecond watt duration. So we have to find the P2P value voltage. So this is P2P. And this is P2P is a 4 multiplied 1 4 volt. Voltage by P is at 2 by 4 by 2 is 2 volt. So this is time. Time is a 6 multiplied 0.1 is 0.6 millisecond. Frequency 1 by T equal to 1 by 0.6 1 by 6 hertz you got. And also the vertical scale channel A 1 volt duration, channel B 0.5 volt duration. Horizontal scale is a 0.1 millisecond duration. In this case, voltage P is a This is the voltage P calculation, and this is the voltage P to P is 1.05 volt. Time is 0.6 minus 0.1 0.6 millisecond. Frequencies are 1 by T, so the 1.5 is 1666 hertz. So this is E is at 5D, so this is the theta T can be calculated. So this is theta T at 360.1 by 0.60 60 degree. Then you have to do this practical exercise. So we are talking about the voltage, vector, and phasor. So at the end of this session, students should be able to define the vector, define the phasor, draw the phasor representation of AC sinusoidal waveform, identify the leading and lagging phase angle, draw and read the phasor diagram. So what is a vector? The quantity dash has a magnitude and direction. This is the phasor. It's a display of velocity acceleration force. A person travels due to the east for 9 kilometers. So this is the phasor diagram like this. A person travels east for 9 kilometers when travel 30 degrees and north of the east for 37 meters. So this is 30 degree measure, and this is the 7 kilometers. And then the starting point, find the ending point you join. So that person this way when you can find it. So that will be 5 kilometers. So this is angle 30 degree. What is a phasor? The phasor representation of electrical quantity. This is the sinusoidal quantity. So this will be the waveform here. This is a waveform. So this is a wave angle and a waveform direction and time moving. This is what the waveform will be going like this. Vector and waveform relationship. If we have a more than one quantity, we add two things. So this two vector is represented like this. Conversion. The reference phasor also is always at 0 degree. The voltage phasor shown by the open arrowhead. Current phasor shown by the closed arrowhead. Phasor rotate in anti-clockwise direction. Phasor rotate. Phasor angle are specified either leading or lagging. The top one is leading, this one is lagging. Phasor magnitude are generally specified RMS value. Phasor addition. Firstly, we have to parallelogram. Then we like this. And then you have to measure the 40 degree. Then you draw this line. And then you construct the parallelogram. And then the one final one. Diagonal is this is for the magnitude. This is a parallelogram method. Then you have to measure the angle and measure the magnitude. So 16 degree. Also the measure with the compass. Measure the compass and then you measure the value. This is 16 volt. So you have to see the example. I am 4 ampere minus 30 degree. I 3 ampere 0 degree. So that will be the 3 ampere 0 degree this line. And 4 ampere minus 30 here. Then you draw the parallelogram. So this will be the diagonal is this is for the resultant magnitude. So this is 6.75 ampere minus 17 degree. This is for the supply 50 hertz volt. This is electric resistor and a coil. We do it 200 volt angle 0. So this is the V1 120 volt angles are 80. So we add the V1 and V2. Then we draw the parallelogram and we measure the diagonal. So that will be the magnitude value. So 250 volt angle minus 28 degree. So 10 angle 45 degree. And then I2 is a 50 angle 20 degree. Then we draw the parallelogram and measure the total diagonal. So that will be the total magnitude 24/5 angle 30 degree. V1 is 10 angle minus 30, V2 is 10 angle 30 angle minus 60, V3 is 20 angle 30. You add. So this is reference current I. So V1, V1, V2. So this is the V1, V2, V3. We measure the magnitude, and then final diagonal. There will be the total magnitude. So this is 27.11 degree. So this is the I1 12 angle minus 30, I2 24 angle 12, I3 24 angle minus 40. Reference voltage ID I1 plus I2 plus I3, you add like this. Then to the magnitude, this one. So then when we measure this magnitude, then will be there 54.45 angle minus 18.27. This is reference 200 angle minus 30. 200 angle minus 30. 250 angle minus 50. Then you go and then you draw the V2 VD minus V1. So this is reverse minus 200. So V1 is a reverse. So this is reverse is this one. And this one you construct the diagram. And this will be the resultant value. V2 is 77 angle minus 27 degree. Then you have to do the exercise. So this is for the advanced diploma Bachelor of Applied Engineering. Then you also have to do the advanced diploma. Bachelor of Applied Engineering, electrical electronic courses. Then we are do the electrical diploma 2022. So you clear the electrical diploma 2022, and you are taking a college document electrical diploma 2022 or 8 p.m. Then go through the video lesson. YouTube video lesson for electrical engineering lesson. So you click this one. So that you can also enter IUI college document electrical diploma